Hi, everybody. I'm Andrew Searle. I'm the product manager at IO Industries. Thank you for attending this presentation about our new rodeo video recorder. For starters, although our Core and Core 2 DVR series have, throughout the past decade, clearly been our most successful DVR products ever, there's been a growing wish list from our customers. The Core DVRs have been able to meet the needs of so many different projects across so many different application markets. But there's always room for innovation and improvement. So we've kept our ears open for feedback. Some of these were met with one or two of the DVR models in the Core series, but never all. And together, they're what's led us to what we have to share today. So things like support for faster link speeds of newer cameras. We've been continuously asked for solutions that can support the newer CXP12 capabilities for co-express. Better scalability for multi-camera configurations, so being able to scale up a system, add more DVRs and cameras over time. Faster download speeds, huge capability to be able to record very fast amounts of data, but you also need to then be able to download it. And download speeds have always been something that have been a bit of a hindrance with the Core 2s. Network connectivity, so being able to connect the DVRs using a network connection, whether that's with copper or fiber cabling. Having a more compact form factor for easier deployment. The Core series, very much was already a very compact solution in comparison to other solutions, but there's always cases where people want it to be smaller. Having live SDI video output and then timing and synchronization with a variety of outside third-party references like LTC, tri-level sync, TTL, GPS, and iRig. These are all features that often made people have to go right to our highest level products, the Core 2 Max and the Core 2 Max server. But it's something that had always been asked for also in the smaller products and the lower price point products as well. And then, of course, last point, as you can see, a lower price. That's definitely something that people have asked over the time for as well. And so I can proudly now introduce the Rodeo. So the Rodeo is a compact, multi-format, multi-frame rate video recorder. It connects to any co-express compliant video camera using multi-link connections up to 25 gigabits a second. So it's a single camera recorder. It's only for connecting one camera ever at a time. It records lossless compressed raw video to internal SSD storage. Today that's up to 2 terabytes of capacity. It has a very fast 10 gigabit Ethernet connection, and that's used for remote control, live video streaming, and high-speed file download. It has an SDI output for low latency live HD video monitoring. As always, we provide intuitive control software, allows you to easily connect, control, and synchronize multiple DVRs and cameras thereafter. And it features precise synchronization between multiple Rodeo DVRs, those co-express cameras connected to them, as well as other nearby devices. So on the input side, it features a co-express video input. This supports either single, dual, or quad link configurations. The link speed can be anywhere from the 3 gigabit per second rate all the way up to the 12.5 gigabit per second link speed, which is the CXP12 CXP 2.0 capable new speeds. Of course, as always, your choice of speeds are going to affect what your total data rate can be, the total cable count, and the cable length. This device supports up to a 25 gigabit per second maximum input speed. So that means combined, you can either have potentially 4 cables, 4 links running at the CXP6 speed, or up to 2 links running at the CXP12 speed. That covers today still a wide range of different high-speed co-express type cameras. The connectors themselves are the HD BNC type, also known as micro BNC. This is a rugged, secure connector. You can find cables with either straight or right angle terminals attached, and it's easy to find these cables. They're also well used in the SDI marketplace, and because they're coaxial type, you can also make your own if you need to. We support power over co-express, so this can provide up to 26 watts of power to a connected camera. And just for reference, you can see some images of comparative connectors. Our previous devices all had the standard BNC, so they were quite large, and we're now using the more compact HD BNC. Takes up a much smaller amount of panel space. And then just for reference as well, if you're not familiar with CoExpress, it's capable of carrying video over very long distance cables. These are just a couple examples based on typical Belden products, Belden coax cable. So for example, at the full speed of 12.5 gigabits a second, using fairly common 1694A cabling, you can run that distance up to 40 meters. And that's the distance between this rodeo DVR and the CoExpress camera that's connected to it. Of course, if it's a lower rate connection, such as a CXP6, then you're into over 50 meters cable distance, and it goes from there. Again, if you're not super familiar with CoExpress, some of its advantages as a video interface are that it uses simple, inexpensive, and long-length cabling. It has very high transmission reliability. It's a point-to-point connection. It has very deterministic trigger timing, so if you need to have very accurate synchronization, trigger signals perhaps sent over to the camera through that interface, it's very dependable in that way. And there's a broad ecosystem of supporting equipment that you can use. So to make that CoExpress connection between the rodeo and a camera, there's a variety of different cables you can choose. Standard cables, converter cables that will convert from one type of connector to another. Multi-core cables, so cables that have a jacket surrounding multiple independent cables, makes it really easy for multi-link connections. And then for very long distance, you can have cable extenders, which will just use additional coaxial cables to extend the length. Or there's also fiber optic extenders, so you can very much increase the distance between the rodeo and the camera that it's attached to. Here's some of the mechanical information. So you can see, very compact form factor. It's very small. You can fit it into the palm of your hand. Very lightweight. It's an all-metal design, anodized aluminum, and it's suitable for operation inside of a up to 30 C ambient environment. You can't see in this image, but there is a cooling fan. It's on the opposite side from the side that you're seeing right now. And this is on to help keep the unit at its lowest potential temperature in that environment. But if there were any issues with regards to audio, like the ambient noise of that fan being on or multiple fans, there is an option so that it can automatically shut off the fan when you start recording. So that's just another neat feature you can use to help, again, maintain the temperature in a nice operating range, but also not impact any sort of audio recording that might be going on at the same time. There's all sorts of mounting points on all sides of the rodeo, different types, either a 1/4-20 type for a tripod style mounting, or the M4 by 0.7 type if you're going to create your own custom plates, let's say, or attach it to a mounting system. You can mount it in any direction. There's no real restrictions. The only real issue is just to make sure you don't obstruct the fan airflow. As far as power goes, it accepts a 12-volt DC input. Power consumption quite low, so overall it's about 14 watts, plus the power that you'd like to supply to the camera through the power over CoExpress. That may or may not be needed here if the camera is going to be separately powered itself, but we can supply up to 26 watts. So we have a standard accessory part called the Rodeo Power. This is a 12-volt 50-watt adapter, so this covers fully the ability to provide up to 26 watts to the camera. Taking this out in the field, then the option exists to use a battery pack of some sort, and this is entirely possible to do. It's actually a lot easier than what was possible in the past with some of the Core 2 models, because it's a 12-volt device, but it does require that the battery pack has a regulated 12-volt output, so it needs to be a nice clean 12-volt signal, which is entirely possible from a lot of different battery packs. And then again, from the very low consumption here, you can have this running on battery power for quite a long time if needed. So the internal storage, we have an internal IOI VidIO drive module. So what this is it's a specially selected solid-state drive that we provide. We ensure that it has very fast speeds, reliably able to write at the data rate that we need to, but also has a very high endurance rating, which is sort of the metric of its lifespan, how many times you can write to the device before it's reached the end of its endurance rating. We're offering models with storage capacity up to 1920 gigabytes. We have the 480 gigabyte and 960 gigabyte models also available. And we will be releasing higher capacities when they are available. So we're keeping our eyes out for options on that. We're testing different modules, and I'm sure that in the near future we'll be having higher capacity modules, 4 terabytes, even beyond as time goes on. These are a user replaceable module. It takes very basic tools to do this. You can get these from, of course, IO Industries or our reseller partners. But in a lot of cases, we don't expect people will be commonly or frequently removing the storage from this device in order to, let's say, take it away and maybe do a download somewhere else with it. The very fast download speeds that we can have with the fast 10 gig Ethernet connection allow you to really use this as its own downloading device as well. So in our experience, because this is a very similar architecture to our VoluCam cameras, it's a much more straightforward approach to just leave the storage inside. But of course, should it be needed to be replaced or changed for a different capacity, it's entirely possible for the users to do that. Here's a quick chart just to show what would be possible based on an assumption of a 2-to-1 compression ratio. And we'll talk a little bit more as we go on, but this has the capability to be compressing the recorded data. And so what it does is actually makes better use of the available capacity, stores more data in that capacity. And you can see here, based on some common resolutions and frame rates, what potential recording time would be possible. So this is the number of minutes that you'd be able to make in total across one recording or multiple recordings before you'd need to stop and have to do a download. So then about the 10 gig interface. So this 10 gig interface, again, it's very similar in function to what we had with the Core series as an eSATA interface. This interface is for DVR configuration, recording control, camera configuration, real-time video streaming, multi-DVR synchronization, and high-speed file downloading. 10 gigabit Ethernet is widely adopted. This is an IT standardized interface. There are many different connection options, lots of available infrastructure components to allow you to create all sorts of different topologies and connection methods to access these rodeo DVRs. The connection is an SFP plus interface, and what this means is it allows for either copper or optical cabling. So the 10 gigabit connection can be made through fiber optic cables, such as multi-mode fiber, which can be up to 400 meters, or single mode fiber, which can be 10 kilometers or even beyond that. Alternatively, for shorter distance applications, you can use an adapter, which then brings this into being an RJ45 connector, and then you can just use standard Ethernet cabling, Cat6a. And lastly, there are what are called SFP plus direct attach cables, DACs, DACs. These are just an SFP plus cable with an SFP plus connector on each end. And these are available with up to 10 meter length. So also another option for short distance connections between the rodeo and the computer that'll be controlling it, or the network switch that's going to be connected to it. So for control software, we have what's called our StudioCap VC software suite. And this is the same software that supports our VoluCam cameras, and now it also supports the rodeo DVRs. This software suite is available for either the Windows, Ubuntu Linux, or OpenSUSE Linux operating systems on either x86 or x64 platforms. The StudioCap VC client is the name of the primary application, and this is the tool that allows configuration and operation of one or more rodeo DVRs and their cameras that are attached, or VoluCam cameras, all from a single intuitive interface. Now, the StudioCap VC software suite includes the StudioCap VC client, as well as other utilities that I'll talk about shortly. But the use of the StudioCap VC client itself requires the purchase of a maintenance agreement, okay? And this is something that is embedded within each rodeo DVR or VoluCam camera. The maintenance agreements and the subsequent renewals can have either 1 year, 2 year, or 5 year terms. So basically, once a maintenance agreement expires, the StudioCap VC client software can still be used because it was originally purchased in an initial maintenance agreement, but no longer can they get any free updates, and then the technical support is limited past that. So definitely something to be aware of. This is a picture that shows the StudioCat VC client. This software gives you interfaces to do live display or recorded display of the video from multiple cameras. It lets you adjust camera settings. So on the Co-Express cameras that have various controls and settings for frame rate, exposure, gain, etc. You need to be able to adjust those and in an easy to do way. There will be various DVR settings that you can control as well, the synchronization between multiple DVRs, control signals for accessing external sync references and time references for the DVRs, controlling the SDI output on the DVRs and such like that. Starting and stopping recordings, organizing the recordings with a production-friendly hierarchy. This is a really great feature that lets you really organize many different recordings into a nice hierarchy structure. It's very useful in a production environment for the the media type customers that we have, but also for just general experimentation applications as well. You want to really segment the various recordings you do into different steps. You can use the hierarchy feature for that. And we didn't have that ever before with CoreView. It was just a very flat hierarchy. This, of course, also lets you export recordings, and it has some extra cool features for creating special calibration and background frame sets. These are often needed if you're doing multi-camera post-processing, any sort of 3D reconstruction or scanning applications. You might need to do these special calibration and background frames and make sure that those kind of travel along with the recordings afterwards for later post-processing. And then just overall, being the tool that checks and displays all the status info and making sure everything is, healthy and ready to go and make new recordings. In any multi-DVR or multi-camera configurations, StudioCat VC client has a really great capability for validating synchronization for all the recordings. So it checks to make sure that every DVR was recording in sync, recording the same number of frames from all the different cameras overall, and then it makes sure that you're notified if that's not the case, because there could be some settings that have not been set properly. And then overall, once you do an export, it makes sure that all the exported frames have matching frame indexes. So frame 1 from camera 1 is also the same as frame 1 from from camera 100, right? So it just really makes camera to camera correlation a lot easier in post-processing if you can just do this all by frame index. And then many different controls are grouped in sort of with apply to others functions, so that basically you can make adjustments on one DVR and then just say, apply all these settings on this DVR to all the other DVRs that I have. And the same goes for the cameras. If I have a lot of the same camera connected to that DVR, then for our cameras, you can actually make it so that you can push the settings from the cameras also to multiple cameras that are connected on the DVRs. So it really just simplifies any of those per device settings you may have had to make in the past when you're setting up a mass, multi-camera system, and just really makes everything as easy as it possibly could be. Now, the other parts of the StudioCat VC software suite include utilities such as a program called Test. This Test client, you can see a screenshot in the top right. This is actually a client tool that's just for only one DVR. So it's basically able to do the same job as the StudioCat VC client to some respect. Many of the other more advanced features aren't part of this, but this is sort of your very basic tool. It lets you get to test one of the rodeo DVRs and just to make sure it's working for you. And it can also be used as the primary application that you use to operate it. It's just that it only ever can connect to one rodeo DVR and then the Co-Express camera connected to that. So it's really just a single camera application. And if all they're using is just a single rodeo DVR and one camera connected to it, then there you go. You can use the StudioCat VC test program for that. Of course, you can also still use the StudioCat VC client program, even if only one camera and one DVR are being used. And there's lots of benefits to doing that. Other utilities include things like device config, firmware update, the export server utility, just helps with exporting across multiple different systems, a config tool, a diagnostic tool, and an IOI file viewer. And an alternative to really using any of our software, the test or the client, Developers can also create their own software to control rodeo DVRs or VolueCam cameras using the StudioCat VC SDK. So what this is the SDK that we use to create the StudioCat VC client and the StudioCat VC test application. It's the low-level API and the access to it to create your own custom applications. Unique thing about this in comparison to how it was with the core DVRs is that this is a license-free SDK. So you may remember that with the core DVRs there was a developer license which gave access to using an SDK for the core DVRs. Well, this is the sort of opposite case where the SDK is actually free to use, so we're encouraging people to make use of the SDK. We include the API itself, HTML documentation that goes into great detail, a few C++ example programs for people to get started with different functions, and then of course some limited technical support for the API itself, and that just makes sure people can again integrate the rodeo DVRs into their own applications, such as like an overall experiment management tool or a range tracking application or something like this, and then make sure that they can control the DVR functions and start and stop the recordings when they know they need to, as opposed to having to use the sort of user-facing client or test applications. Okay, so moving on to video monitoring. So how do you see the pictures from the cameras that are connected to the rodeo DVRs? So we have two ways to do this. One is through the live video interface on the 10 gig connection. So you can either have live video or playback streamed through 10 gig for display in the control software, whether that's our control software or the custom created control software. This live video stream is a 3 megapixel resolution of live frames, and they can either show a direct 1-to-1 pixel crop of the input frame from the camera or a downscaled full view of the camera frame. What this does is actually really optimize how fast we can refresh the live rate, as opposed to trying to stream full resolution images from multiple rodeo DVRs all the way back to one computer. Alternatively, there is a low latency full rate SDI output on the back of each rodeo DVR. So this is a full HD 1920 by 1080 SDI video output, and it can be running at any of the rates supported by either HD SDI or 3G SDI up to 60 frames per second. And so it's showing you a 1920 by 1080 center crop of the 10 gig's live view. So whichever settings you've used to adjust what you see through the 10 gig live view, whether you're showing the 1-to-1 crop or the full scaled view, you see then a portion of that through the SDI output of the DVR as well. So that can be connected to a nearby monitoring system. You can have a multi-viewer system, and it's unlike the 10 gig where the computer's job has to be to receive all those frames and display them all, and there might not be the ability on a particular computer to display, let's say, 10 different feeds at the same time. You can always rely on the ability that the SDI equipment will be able to display at full speed. So if it's a multi-viewer system and it's got 16 inputs going into it, you're still going to get 60 displayed images per second because it's video, it's an SDI signal, it's not being processed and shown through a computer interface. So this is really something that can help, especially if you want to give a wide view that multiple people can be looking at of the video that this DVR happens to be seeing. A quick look at the back panel. So you can see we have a variety of different interfaces. What we have is an LTC input, and that LTC is linear time code. So this is a way that we can bring in a signal for time sync and or shutter synchronization for the camera. And that's on a 2.5 millimeter headphone style jack. We have the power connector. It's a 4-pin latching connector. This is where the 12-volt DC brings in. We have below that, just to the next, it's the tri-level sync input. This is an HD BNC connector on the back of the camera. Tri-level sync is a way that we can also have shutter sync for the camera in case we need to sync with other devices that use tri-level sync. We have an auxiliary connector. That's a 6-pin connector, and what that has is 5 different 5-volt TTL input-output signals. So this is like the aux IO connections that we'd had on the core recorders. So we have 2 TTL inputs and 3 TTL outputs. So with various reasons people would use TTL IOs, whether that's to bring in trigger signals for starting and stopping recording, or camera sync signals, like 30 hertz signals that will come in and then trigger the camera at that rate. You may need to use one of the inputs. The outputs can be used for things like status. We can have logic signals go out when maybe the DVR is recording, or maybe when it's ready to record, or for example, you can have output signals come out and then daisy chain through a multiple set of DVRs as well if you need to cascade a signal across multiple DVRs. Next is the SDI output. It's also an HD BNC connection. The 10 gig SFP plus connection, that's the cage that you see on the bottom right. That's where you can attach the small form factor pluggable modules for various different 10 gig cabling options, fiber and copper. And then we have a couple indicator lights. So we have a drive LED, just gives you some status on whether the drive's active. And then we have a status LED, which is just overall operating state of the DVR. Synchronization. So we have a variety of different ways that we can achieve multi-DVR, multi-camera synchronization. And the reason you want this is so that you can have many cameras, taking images at the exact same time, with their exposures lining up with each other, and then their timestamps, correlated across them as well. And in many cases, we can do this very simply using what's possible through the 10 gig interface, which is called IEEE 1588 Precision Time Protocol. So PTP is something that we support with these rodeo DVRs, and it's supported in one of two ways. If you have a small closed system where you just have a number of rodeo DVRs connected to a network switch and no other third-party equipment, then one of the DVRs can be designated to be the PTP master. What it does then is it generates PTP packets and transmits them to all the other DVRs to synchronize their internal clocks to its internal clock. And then the other option is to have the DVR as a PTP slave. So that's where those other DVRs would be receiving the incoming PTP packets. Now, that could be from that master DVR, or it could be from a separate PTP grandmaster clock. And the grandmaster clock is just another device that's on the network that's acting as the PTP master. And that could be a third-party device. It could be a very accurate time clock that's synchronized to an external time reference like GPS or iRig. It could also be another third-party camera system. It could be a motion capture camera system that you might want to synchronize the rodeo DVRs to, for example. So PTP is very flexible, very accurate, and it's a great way that you can do this while also minimizing the cabling and not having to use a lot of additional signals between the DVRs. But of course, as I mentioned, you can have great local synchronization with third-party devices such as audio recorders, even motion capture cameras that do this way, other video cameras, other data acquisition systems by using the interfaces I mentioned before, which is the linear timecode LTC, the tri-level sync, or TTL connections. So lots and lots of different ways to do synchronization. Almost every different project calls for a different way to do it, and we've probably covered it in one way or another before. So it's probably most of the cases to involve a little bit of discussion and consultation on what's the best way to do synchronization for a project. And we're happy to kind of go through that with people and just make sure they're using the right features for the right jobs. So how is the video recorded? Well, we record raw. So we're basically taking the data exactly as it comes from the CoExpress camera. We're not changing it at all. We don't apply any sort of demosaicing to turn the raw video into color RGB video. We just store exactly what we get from the CoExpress cameras, which is how we've always done it. We can store up to 16 bits per pixel, and this really ensures that people can take that high quality pristine data and use it afterwards. For whatever reasons that they need to, they can rest assured that we're not dropping any information, losing any fidelity. We're recording it exactly as we got it. Now we are using lossless compressed recording. And this is by means of an FPGA-based, mathematically lossless intra-frame compression engine. So this is something that's running in the FPGA inside the rodeo DVR. We're taking the raw data and we're compressing it frame by frame. We're not using neighboring frames to choose the compression, so it's an intra-frame compression. And basically speaking, we'll be able to compress up to the limit that the detail in the scene allows, basically. So in a general sense, and I'll show some examples, we're seeing compression ratios approximately at a 2-to-1 ratio. So lossless compression, it's like what you think of when you put files into a zip, archive. We're not seeing a drastic amount of decrease here. We're not talking about 10-to-1 or 100-to-1 compression ratios like you see with, security camera, video recording systems. But in general, compared to what we had before with the core recorders, which was just purely uncompressed recording, we're able to have an increased recording time for the same unit amount of capacity. The same unit amount of video data recorded, can take almost half the time to export because you're moving half the amount of data. And then therefore you have less storage capacity required for those exported files. So it's a very much more efficient way of storing the data. And it's something that's definitely come from a lot of advancements on our side to make this possible. So you can see how it works in practice. If you're inside our tool, this is the StudioCat VC client. What you see for the record time indicator is actually it's like a representation of what it would be if it was uncompressed, and then what it's looking like it will be because it's compressed. So you can see in the indicator, in this particular use case, we've got it saying if it was uncompressed, you'd only have 10 minutes left. But based on the current compression ratio we're seeing, based on the current scene detail, it actually has about 20 minutes of recording time left. So this indicator is actually updating in real time as you're sitting there. If you see something wildly change inside the scene, or you change the camera settings and you add different amounts of gain, for example, you'll see in real time what the effect is on the record time. So yeah, you can see in this example, this is a fairly generic scene, properly exposed, low noise, and we're seeing about a 2-to-1 compression ratio. In this case, on the left is an overexposed scene. So you can see there's a lot of redundant pixel data in the image, a lot of neighboring pixel values that are exactly the same to each other. And that's really what helps to improve compression. And you can see in this case, this scene has a 5-to-1 compression ratio. So where we would have only had 10 minutes of recording time, we're seeing it tell us what we can record for almost 50 minutes. And on the right is like a very high noise scene. So this is a case where the compression ratio is actually a lot closer to uncompressed because there's just not enough redundant information that we can compress away. So this is where you will come into cases where you're not really seeing much of a benefit from the lossless compression, but in any case, it's actually quite aggressive, of a scene adjustment from what the normal camera capabilities are that you have this result. So this was with like almost all the gain turned up, and it's not really an optimal setting on the camera. So in general sense, we're seeing quite positive compression ratios. So once you've made some recordings, what happens next? We have to export them. We have to move them, take the data from the rodeo recorder, move it through the 10 gig connection, and then store it somewhere on another location. The recordings themselves get exported primarily in what's called an IOI file format. So the .ioi file format, it's a proprietary, raw, single image container format, something we've come up with. Of course, it's matched particularly to the compression algorithm that we created for the rodeo. And what we include with the software suite is an IOI image viewer tool. So right away after you've exported these images into IOI files that you've recorded, you can open them up in the IOI image viewer tool. It's an easy way to zoom in, zoom out, pan around the image and see what the picture looks like. Quick buttons to view the previous and next files that are in the same folder. You can look at the metadata, and very quickly you can save this into a DNG format. So a DNG image is a uncompressed, standardized raw image container. So DNG, or digital negative, is a fully supported file type. It was created by Adobe. Many different photo and video editing tools support DNGs. So we have a great immediate pathway to convert to DNG, and that's just one of the options you can have as a sort of a data workflow. But there's also many others. So the other options is that we can actually convert to DNG automatically during the export process, so that you never see the IOI files on disk. It directly converts them into DNG in the process. totally an option if you want the data to immediately go into the DNG format. It's just that there's an element of decompression that has to take place, and so that can have a little bit of a time hit on the export process. It also then is going to take up potentially 2 or more times the storage capacity that the IOI files would have taken. So that's something to have to consider as well. We have post-export scripts that can be executed automatically by the StudioCat PC client. So again, this is the more advanced recording software tool, and what it has is ability for you to specify a post-export script. And a post-export script is just a standard Windows batch file, and what it can do is call additional libraries for image conversion, so that once the IOI files have been exported, or the DNG images, it can then kick off a process that takes those and converts them into, let's say, an MP4 movie file or a bunch of JPEG image files. So there's a variety of different ways that you can reach to having the final file type that you want to have if you want to export to a particular file format other than our IOI container for archival purposes, or DNG images for the same reason. Alternatively, developers can use the API to open and access the IOI files directly. So let's say you've written a software analysis tool for particle tracking or for motion analysis. You can just use our API. Again, it's license free. You can then directly access our IOI files and get the contents of the files and begin to process them directly from their native storage format. Again, very efficient way to do that. Also, there's a third-party image processing tool that's called Fast Cinema DNG Processor. This is like a batch tool that can open a whole folder full of IOI files and then save into an MP4 format. And along the way, you have all sorts of different other image correction and enhancement tools that can really bring the most out of your images as well. So that's a third-party tool that you can check out as well. And lastly, another feature that developers can do is use the API to build a custom export frame processor. So again, if you're thinking, okay, I'm building an application, I want to be processing the data anyways, you can actually make this export frame processor thing where the third-party application actually just receives the frame buffer data directly instead of it being written during the export process into a file. It's just there's a few different ways that you can go about doing this, but this is another way of having it. So bottom line is, application developers have a few different ways to get at the IOI data files. The IOI data files themselves are a useful container for the raw data they've just recorded, but there's also easy pathways to converting them into other different types of files as well. You can see here that we have some different hooks in the Windows OS, particularly where we have a codec that displays the thumbnails of the files in the Windows Explorer. So these are IOI image files, but you can see a thumbnail for them. In often cases, many other proprietary files, you have no way of sort of seeing a quick view. We view a context tooltip, and that just gives you some information at a quick glance, and then you can also see the file properties as well. So file export. So once again, the Rodeo DVRs will export through a 10 gig network to a PC. And this will either be the PC that's controlling the DVR or a separate dedicated export server PC that's just another PC on the network. We can make recommendations for you about what the sort of architecture should be for these systems. Of course, for best results, the fastest export speeds, you want to have to choose something that has very fast and high capacity destination storage. This is always the same story we had with the core DVRs, where the exporting speed to some extent was limited by its host interface, the eSATA connection. But then also, if all you were doing was exporting to a USB connected hard drive, that's going to be your bottleneck to the overall export process. So the 10 gig connection, the fact that we can make this divided up and split from multiple DVRs going to multiple export destinations, all in parallel, the opportunities for scaling up the export are kind of endless in this case, and it really opens up the doors to have a very quick workflow from recording to exporting and then returning back to recording. And so that's where I say, yeah, the multi-DVR and multi-camera systems can export to several parallel export server PCs. So we can, again, get into those conversations with your customers and people that need to know about this as the opportunities come up, of course, just so that we can help guide them in the right options that they have for that. It's important to note that exporting can only take place when the DVR is not recording. So you have one option or the other. You're either recording or you're exporting. And one last thing is that to also help further pipeline tools, you can create this extra XML file every time you do an export, and it just contains a whole bunch of recording details and then maybe the notes that you wrote down inside the software in order to assist any sort of downstream processing tools. So here's a quick look at how some of the configurations might be based on how somebody needs to set up a system of various co-express cameras. So if you just have a single camera, you can easily put a rodeo on the back. Think of it almost as like a backpack device. And then you can use a laptop, to be the controlling system. Now, you do need to have a 10 gig connection. So the laptop can either have that potentially on board, or what we've used pretty commonly are these Thunderbolt to 10 gig adapters. So it's a very inexpensive add-on device for a laptop that has a Thunderbolt interface to give it a 10 gig interface. So then from there, you can connect easily directly to the back of the rodeo. And then, for example, you could use, like I mentioned before, the DAC type of cable, which is a good short distance cable, good latching connection between the 10 gig NIC adapter and then the back of the rodeo. Moving on to a multi-camera system, if you have a few different cameras, what you would use is a small, compact 10 gig network switch. There's a variety of different options out there. They could have anywhere from 4 to 16 10 gig ports before you start getting into using, much larger switches that have 30 and 40 switch ports. But you can get a pretty compact one that has, only 4 or 8 or 16 ports, and then from there you can connect as many rodeo DVRs as you need. This is a great way that you can also bring in an external time reference. Again, to do that easily, there's a few different options for PTP Grandmaster devices that get an external time reference from either iRateB or GPS timecode. So you'd have that connected to the switch, you'd have all the rodeos connected to the switch, and then you'd have the computer connected to the switch. And everything together talks together. They share the PTP time to synchronize everybody, and then from there, you have an easy system to set up, and again, also very straightforward to scale it up afterwards. Easy to add additional DVRs as you need to, just limited really only by how many ports you have on that switch. And then this brings us to sort of a broad scale application where you can see a very massively multi-camera system can be set up using a variety of the rodeo DVRs connected to a variety of either IO Industries or third-party co-express cameras. And then also in the same system, you can tie in the use of our VoluCam cameras as well, because they seamlessly work within the software together. So of course, if the sensors that you're looking to use are already incorporated in the VoluCam camera family, then that's great. If you're looking to augment that then with higher resolution, higher speed sensors, of course, then of course pair those kinds of cameras with the rodeo DVRs, and together you can build a complete system of many different types of sensors all working harmoniously together. You can have external sync references brought in, you can have external time references brought in, and everything really condenses on a 10 gig switch. And again, this could be one switch, it could be multiple switches. We've had systems set up with over 100 of our VoluCam cameras, and the rodeo DVRs have the same architecture. So it's very straightforward to take multiple switches, join them together into a massive network, and that just lets you grow the number of devices that you can connect to at once. And just an example here of an actual case where this has been done. This is a system that's been deployed at a studio called Avatar Dimension. This is in Washington, D.C., and they have 70 of our 12 megapixel VoluCam cameras. The architecture is very straightforward for them. They have a couple different switches that they all connect the cameras to, and the same would be true if it was the rodeo DVRs and a co-express camera nearby. This is just to show that it's entirely possible and doable to have very large numbers and systems set up, and really not have to worry as you grow this that the performance of any one unit is going to be taken away from. So what are some of the common applications that we see the rodeo being used for? Volumetric capture, that's what the Avatar Dimension people do. It's for very truly lifelike reproductions of human performances. What you'll have is a suite of different cameras surrounding an actor, and they'll capture them from all sides, and then turn that into a 3D reconstruction. It's very realistic looking. The same goes for 4D facial scanning. And in all these two cases here, it's a requirement for very high bandwidth, high resolution cameras, perfectly synchronized together and recorded over long sequences of time. So it very much lends themselves to our technologies, and we've got a great amount of experience providing solutions into this space. As well, motion analysis, just in general. So any sort of kinesiology, behavioral studies, biological research, any sort of human motion or animal motion, insect motion, it's all within the realm of the types of resolutions and frame rates that our cameras, as well as our DVRs and third-party cameras, all together are able to capture. Okay, we're not into the space of, ultra high speed cameras for these types of applications. You don't need to have thousands of frames per second. You don't need to have, the ability to see glass cracks propagating. It's really the case that you need something a little bit more than what a typical standard video camera could offer you. They want a couple hundred frames per second, for example, but it all has to be nicely synchronized and perhaps even tied in with other third-party data analysis systems. So very much a core market that we've had a lot of success with in our past products, and will be very much the case also with the rodeos as well. Aerospace and defense testing, very similar in that way, and again, a lot of the design inputs that we have, and the reasons that we make the devices rugged and all metal and more tolerant to different environments is because of the applications that are used in the aerospace and defense testing markets. So really just the miniaturization of the technology, making rodeo as small as it can be, is only going to help fit this device into more and more exciting places than we were able to before with the core series. And the same goes for the commercial research and development markets as well. Same goes, where the fact that it's so much smaller, so much more easier to set up and deploy, easier to connect to multiple systems and then support a variety of different types of cameras, it's going to make this DVR just as suitable and more suitable than any of the past DVRs that we've been able to supply. And so the resources that we have available for people from here is the access to our website. You can go there and find information about the rodeo DVRs, find out specifications and photos and such, get access to the data sheet and the user's manual. We have an online DVR storage calculator, really friendly, easy to use. You can plug in specifications of the kinds of cameras you want to connect, plug in which of the storage modules you think that you might use, and then it'll tell you here's estimated record time based on a 2-to-1 compression ratio, which is a pretty safe bet. Here's how much, how many minutes or hours you might be able to get to record with. So very easy to use. I definitely recommend experiencing and playing with the DVR storage calculator. Okay, so from here, if you have any questions or if you'd like to set up maybe a more detailed discussion on this, please just email us at sales@ioindustries.com to start the conversation. And also please check out our social media, keep in touch so you can see any sort of announcements that we make. A couple links below for LinkedIn and Twitter. Thanks again for sitting in on the presentation. I hope it was very interesting for you, and we look forward to hearing from you with any questions you might have.